Hey, welcome back to the J44 project. This video is, I guess, final assembly part 6 ongoing, and today I'll show you a clip of installing the compressor bearing retainer, getting everything torqued, the seals, and how that all works. That'll be done. That basically then now it finishes the main core of the engine. We'll then turn our attention to outside accessories, because from now on, or from here on out, we will be installing accessories onto the engine, including plumbing and electrical connections involving the accessories. But before we go, there was a question kind of brought up by Beach and Board Fan, and one of my a couple of videos ago was talking about the modified fuel cell and what Mark had done to basically, we cut the top out of the existing fuel cell, and then he made let's just call it a box with an open bottom to fit exactly over the outside of the existing fuel cell. So, and then welding it in place, in effect doubling the height. Basically same inside dimensions, but now it's twice as tall to increase fuel capacity. Well, when he did this, in his design, he had cut the bottom edges of his so-called cut new top in a sinusoidal wave pattern, like a scallop, and then the weld is in a scallop. I incorrectly stated that that was done maybe to prevent warping during welding. Well, when Beach and Board Fan raised a question, it was like, what was that about? That's interesting. He'd like to hear more about it. So I did ask Mark about it, and it has nothing to do with warping. It has everything to do with strength. If you do a butt weld, 2 pieces of metal, which would say be the upper half of sheet metal and the lower half of my existing cell, just a straight weld gives you this, or let's look at it this way, but the fuel, it will bend. And he said the fuel sloshing around will constantly pound on those sidewalls, which it would. And if you flex that over time, that weld can fail. By doing the scallop weld, we have a lot stronger, less flexibility. You see what I'm getting at? In effect, it makes the seam way wider than the actual narrow bead of welding. It distributes that force over a wider area. So there you go, there's a reason for everything. It's a stronger bond. Let me show you what we're talking about. I'll take the camera off the stand. Okay. You can see the wave here in this cut, and then the weld, but the metal, this upper piece is cut on purpose here that way. And then upon welding it to the lower part, it's a wave. So okay, so you can see what he was referring to. So there's your answer. Beach and Board Fan, appreciate your question. So I don't get too many questions, and I appreciate them. At least once in a while, you know, it's good somebody's paying attention. All right, we're going to show you a little bit about some of our accessory band is on, and we got a couple of the fuel system components installed. So it's starting to look like something. I have a clip of gasket making and some little ways to do it, so it's real short. I'm going to throw that in on this one too. In order to keep the videos from being too long, we'll just cover those few topics, and then we can wrap it up, and we'll make another video. We got some more, we're starting to get some material together now, so I actually have a little progress here and there as I can, and it's getting exciting. We're going to take a look now at installing this compressor bearing retainer. So here we go. Okay, we're going to show you a close-up here. Here's the bearing retainer, front view. We'll turn it around. Okay, here's the back view. This is a shim, this little metal. If you look at it, it's a very thin piece of metal. There we go. And it is used to, the shim is used to provide the correct pinch against the bearing race. It holds it in place against the outer bearing race. This O-ring is a seal between this between this retainer piece and the case. Then we have an inner seal. This is a lip type oil seal, and that is the seal obviously around the shaft. Okay. The replacement seal, as close as I could get, ended up being a bit thinner and but the same diameter. So what we had to do is make a spacer, like 160 thousandths or so, to space this seal further back in this bore or in its seat, so it would ride and mate with the shaft correctly. So what that did was that brings the primary sealing lip to back here flush with this housing, so that it is where it needs to be on the shaft. Okay, here's a hot tip for you. Take your favorite small glass bottle, which has a little shaker top on it. It screws on. You can remove the cap and you got a little spout that'll dribble. This is a hot sauce bottle, to be exact. In fact, it is Frank's Red Hot, the original. But it's been, the bottle was emptied, product enjoyed, and then we washed the bottle, dry it, and now it's got turbine oil in it. This is a fairly easy way to dispense the oil in little small amounts for during engine assembly when you need to lubricate seals and such bearings and things like that. So it's clean oil, keeps it clean. As you know, everything needs a little lube, so we put a little oil here. We're going to lube the end of the shaft, and we're going to, maybe it's a little bit on, it's already oily, but this machined aluminum surface here inside that this retainer fits perfectly to. Okay, we're going to put a little here on our shaft seal. Make sure it's lube because you don't want dry. And we need to put a little on this O-ring just as well, because that too, the O-ring will have to seat, and we don't want it to pinch or cut. And with it being oily, it will be a little more compliant. Slip it right where it belongs. There's this little groove machined in the face here, which is the place for this groove, the place for this to seal up against the case. Alright, so now we cleverly marked it top here with a marker, so we know right away. This only goes one way, so you sit there and spin it around to match up the bolt pattern, but if you just mark it, it'll go right on there. And look at that. Now the part is, we got to press this in here and make sure it fits over this shaft without too much trouble, and there it went. Yeah, that looks pretty good. There you go. Alright, well, we're going to take a look at this with a flashlight. I'll tell you what, it looks pretty good. Now we'll install these nuts, and then we can torque them down, and we'll have us an installed and clamped in place, and hopefully theoretically completed this would complete the main core of the engine, this being torqued down, because now we've gone from the front to the back, the bearings are sealed, everything's in place. Everything else from here on out is peripherals or externals. Alright, we're going to install our washers. We have some AN washers here. And we'll get these in place. Then we put the self-locking nuts. These do not require lock wiring because they're self-locking fasteners. And many people ask, and even I do sometimes, I wonder why you can't just use those everywhere instead of having to do all this lock wiring. But there's a reason, I'm sure, and it's beyond me. I'm sure there's, depending on the environment, that it's permissible. I don't know. It looked like it would be a time saver if all you had to do was tighten the fasteners. And they're done. You don't have to go back and spend hours lock wiring. they're all started and they're up to the self-locking material, so now we have to put the old socket on. And doing this, if you see I'm holding right on the head of the ratchet with a very short handle, this is just to hand tighten, run them up, not even hand tight, I just see it pull two and I'll stop, and then we'll get the torque wrench out, so these draw down as even as possible. No torque here. Low torque. Okay, there we go. Now they're all snug by hand. And then we can torque wrench them. So we're going to look those specs up. Alright, we've got a trusty manual here. Let's look up these compressor bearing retainer nuts, stud nuts. They're nuts on studs. So let us see here. I think it's in the back, if I remember right. Here we go. Special torque values. Continued. Special torque values. Let us look here. Okay, here we go. Nut, comma, compressor bearing retainer. This is the compressor bearing retainer. It is 100 minimum. Okay, it's in pound inches or inch pounds. Minimum 100, maximum 140. Okay, so 100 to 140. So 120 would be about halfway. Let's shoot for that. There's a trusty snap-on little inch-pound torque wrench, 3/8 drive. It's a nice little tool. Okay, let's get us our. We'll get socket set up here. I don't know where these are at now, but we'll see if we can start at the lowest scale and get them all the same. And that's 30 inch-pounds. That's the lowest it'll set. A deep well 6-point socket. Pretty rigid, pretty solid. 6-point won't slip. We'll zoom this dude up in here. Okay. We're set to 30 inch-pounds. Let me stand here so you can watch. We'll just start with 12 o'clock here. It's already that tight. Let's go to 80. We'll just do 100 and then we'll go on and do 120. This is all aluminum stuff, so I try not to draw it up evenly. Don't be in a hurry because torque it all up at once and you may warp something. Okay, here we go, 120 inch-pounds. You can tell the sound changes as we keep increasing the tension on this mechanism in this wrench. And it's done. Yay. The engine's closed up officially as far as the bearings and seals and from one end to the other. Now I just need to add the stuff to the outside of it. Okay, now let's take a look at the accessory band clamp and several of the fuel system components installed on it, including some of the basic, including some tubing and plumbing. All right, you see our accessory band clamp installed. It's two pieces that come together here, and then 180 degrees from this point on the opposite side. There's also two screws, and then up on that they have locked nuts or trap nuts or U-nuts to which we can fasten our fuel system components, this being the acceleration limiter. And if we duck down here with less light, let's try to get in here. Okay. And it's the talking clock lady there saying it's 11 o'clock local time. This is our fuel. This is the fuel shutoff valve. Okay, so we have that installed on the bottom here. This little line right here is actually the line that delivers fuel from the acceleration limiter here to the valve and through the valve to the manifold. As you can see, having these installed allows me to start figuring where the plumbing's got to be connected. All this has to line up. These are pre-bent pieces from the factory. We'll move over here and take a quick look. This is the main fuel filter for this engine. It is after the pump, but before the fuel control and sit part. So the fuel is pumped up to pressure and forced through this filter and then plumbed to the fuel control. So there we go. That was a little, not much here, but again, it's starting to look like something. Okay, I have one last little blip to show you how to make your own gaskets. This is very short, very simple. You know, just use your imaginations. Many things on old projects like this you can't get gaskets for, that you have to make your own. The main probably the main issue would be being sure of the material that you're using for the application or the place on the engine you're making a gasket. Sometimes it's heat, lots of heat. Other times it's fuel or oil. So sometimes it's just dry, it's just air. Or so there are so many different types of materials available. You want to be sure what you're using is appropriate for that use. You would have to maybe find out or know halfway what your surroundings are. Like I said, temperature, pressure, and liquids, solvents, fuels, oils. You need to know those surroundings, and then you can determine what type of material to use. You buy the gasket material yourself, and then you will trace out and cut your own. Here I was making a gasket for the igniter spark plug that goes in this engine. So let's take a look at that now. Here we are making a gasket for the igniter. You can no longer get these parts, obviously, so you make your own. Just found something that was pretty close, almost exact, the diameter of the outside of the gasket, and we just traced that out here. And then this washer is like exactly 1 inch outside diameter. We use that for the inside. Once that was cut out, I placed the igniter plug through there and traced around the 3 mounting holes. And then you just take in this case, a 22 shell, 22 long rifle shell, rimfire cartridge, and it is a nice punch. And you just hold it with a pair of these pliers, and you wrap it with this little brass hammer, and you got holes, nice clean round holes for the bolts. So there's some more creativity, I think. Okay. I'll take a pair of scissors. We'll cut this out, the outside out. We have us a new gasket. Then we can install our igniter plug. Okay, there you go, gaskets. So let's sum this up. We'll close this video down, wrap it up, and we'll be ready to move on to the next. So I hope you all could see something here as progress and get your faith in me revived. We'll see you on the next one. Thanks a lot for watching. I appreciate your questions, comments, and you have a good day. Cheers.